I shall start with angle of depression. Let me start with an example. Suppose that there is a cliff by the sea. So that's the cliff and that's the sea. Okay. And suppose that there is a person there. And let's say he is say 40 meters above the sea level. Let's say the 40 meters goes up to his eyes. Okay. Now he looks down at a ship, a boat down here. Let the boat. So he looks down at this boat and he finds that the angle of depression of this boat is 20 degrees. Now what this means is that if he looks at horizontally, he would be looking along this line. So this is the horizontal line from his eye. And if you look down by 20 degrees, he sees the boat. So that's what it means by angle of depression. It's the angle that you have to look down from the horizontal. So for this person, 20 degrees is then the angle of depression of the boat from his point of view. So question is, find the distance from the boat to the cliff. Okay, let me call that x. So that's the question in this example. Now there are quite a lot of details here: cliff, seawater, boat, man, eye, horizontal, and so on and so on. To do this calculation, we need to pick out the relevant details. Right, we can look at the 40 meters, which is this height, the 20 degrees, which is that angle, and we want to find this distance. So let me think about this triangle here. Okay, and I'm going to draw that triangle here. Okay, so this is where the person is. This is the foot of the cliff. That is the boat. Alright, so boat, person, and foot of cliff. Alright, but there is some horizontal distance from the person to the foot of the cliff. Alright, they're not along the same vertical line. Otherwise, the person will have to be standing at the edge of the cliff, and that would be really dangerous. But because this boat is probably some distance away, we're going to assume that this distance is very small. So I'm just going to take it that the person is just directly above the foot of the cliff. Okay. And then there is this horizontal line. Alright, that's the horizontal line. So I've left out pictures of the person, the boat, and the cliff and the seawater, and just have a simple triangle. And let's put in the numbers. So that height is 40 meters. That angle of depression is 20 degrees. And x is this distance, which we want to find. Okay, so now we have a simpler picture, and in order to find x, right, notice that this line is also horizontal, just like this dashed line. So they are parallel, and therefore these two are alternate angles, which means that this angle is also 20 degrees. Okay, so now we have a triangle, right angled triangle, vertical 40 meters, angle 20 degrees, and we must find x. Alright, so for this angle, this is the adjacent, this side is the adjacent side, and that's the opposite. So the relation between them would be tangent 20 degrees equals to opposite over adjacent. And that gives us an equation that we can use. So if you rearrange that, we can make x the subject. Okay, and if we use our calculator, we can find an answer. And that would be, because 40 is in meters, so this would be in meters. So that's what angle depression is about, and we can use it trigonometry to work out problems like that. Next thing I'm going to talk about is the altitude of the sun. Now the altitude of the sun is the same as the angle of elevation of the sun. So the angle of elevation is the opposite of angle of depression. So instead of looking down, we would look up. So let me think of an example. Suppose that that's the ground and on Earth, and that's a person there, and we have the sun high up, very far away. For this person, the angle of elevation of the sun means that if the person looks at the sun, then that angle is the angle between the line joining the sun to his eyes and the horizontal line from his eyes. So that's the angle of elevation. So let's take, for example, an angle of, say, 60 degrees. Okay, that doesn't look 60. Okay, let's say this is 20 degrees. Okay. So let's look at an example, right? Suppose that I have a tree. So I'll let me draw another picture here. So a new diagram. Suppose that I have a tree like that. Okay. And I have a sun down here. So if the angle of elevation of the sun is 20 degrees, that means that if I draw a line from the sun to anywhere on earth, I can draw the line to the top of the tree, I can draw the line to the bottom of the tree, I can draw the line to another place. The angle that the line makes with the ground would always be the same. The reason is because the sun is so far away. Alright, which is why if we are outside in the sun, we'll find that no matter where we walk, the sun always seems to be at the same height. So in this question, suppose that we are given that the angle of elevation of the sun is 20 degrees. And we are also given that the tree is, say, 10 meters tall. So the sun would cast a shadow of the tree on the ground. So this will be the tree shadow. Then let's try and find the length of this shadow. Right, let me call that x. From there to there. Okay, so we are given that the angle of elevation of the sun is 20 degrees, the same as that. Now if you look at this, it means that this angle is also 20 degrees. So now we can, if we look at the tree and the shadow and this line, you see that there is a right-angled triangle down here. Alright, this is the hypotenuse, that's the angle, that's the adjacent to the angle, and this is the opposite, the vertical through the tree. The vertical through the tree is 10 meters, the height of the tree, and that's the right angle. Okay, so the relation between this opposite, the adjacent, and the angle is again the tangent. Alright, we know that tangent 20 degrees is equal to opposite over adjacent. So now we have an equation and we can solve for x, the length of the shadow. So x is equal to, if we exchange those, 10 over tangent 20 degrees. Then we can use our calculator to find an answer. And since that is 10 meters, since 10 is in meters, the answer would be in meters also. Right, let's look at another question on angle of elevation. Okay, let's say that's the ground. Suppose that there is a tower. Okay, there's a tower of some sort. Okay. And there is a person somewhere here. When it's here, you look up at the top of the tower and he measured that this angle is 45 degrees. Okay, then he walked closer to the tower, and when you look up again at the top of the tower, he measures this time an angle of 60 degrees. And here, and from here to there, let's say he has walked a distance of 80 meters. Okay. Then let us try and find the height of this tower. So we are going to simplify things a bit by thinking that the person is a lot shorter than the tower. Right, that is a very high tower, so that compared to the tower, the person's eye, right, which looks at the tower, is quite close to the ground. So we can ignore the distance between the eyes and the ground. Okay, that means we just think of this line as coming all the way to the ground. So then what we have here is we have two lines coming to the ground. We have this horizontal line going from the person to the bottom of the tower, and we have this tower going straight up. So we can think of this as a triangle and this as another triangle. So let me draw this out separately to make it less confusing. So that's the tower, that's the H, that's the horizontal distance. This line is here, that angle is 45 degrees, and then 80 meters in we have another line. This angle is 60 degrees, and this would be a right angle to the vertical. So now we want to find the height. We can think about the relation between the angles, or each angle, and height, and maybe the horizontal distance. Now we know if I have a triangle, right angle triangle, and that's the angle. Okay, and let's say that is the right. That would be the opposite. That's the adjacent. We know that these are related by tangent theta. Tangent of the angle equals to opposite over adjacent. So we can try using this tangent formula here. Let's see what we can do. There are two angles here, so let me think about, say, that angle. If I want to think about tangent of 60 degrees, then according to this relation, tangent 60 here should be the opposite over this adjacent, but we don't know what that is. So if you don't know what it is, let it be x. That's what we do in algebra. So tangent 60 degrees is then h over x. And hopefully we can either find x or get rid of it afterwards. Okay, now the other possible relation is for this bigger triangle between h and 45 degrees. So let's think about tangents of this angle. That should be equal to, that's the opposite, and this time the adjacent is here. So opposite over x plus 80. Okay, so what we have now are two equations, and we have two unknowns, h and x. So in principle, we have two simultaneous equations and two unknowns. We should be able to find h and x. Now if you remember, the question is to find the height of the tower. So we really want h. Okay. Now let's do some simplifying. One place to start would be to try to get rid of the fractions, meaning to rearrange each equation so that it is not a fraction anymore, because fractions are usually more difficult to work with. So if I want to get rid of this fraction, or turn it into something that's not a fraction, the first thing to do is to get rid of the denominator x. We can do that if we multiply both sides by x to get, so that gives tangent 60 equals to h. This is the same as saying we move the x to the other side. So that looks simpler. Let's try it on this as well. The x plus 80, let's multiply both sides by x plus 80. Then we get x plus 80 on this side. Okay. Now when we do this, it is important to understand that if you look at this expression, it looks like we have an 80 times the tangent 45 degrees. Okay, and we are supposed to do times before plus. Okay, but that would be wrong because x plus 80 came from here, and we know that x must have been added to 80 first. So we need to put a bracket around it, alright, to make sure that x is added to 80 first before we multiply by tangent 45 degrees. So now we have the two equations in this form, in which we have the same h on the right hand side. Right. Now h is really what we want to find. We don't really need to know x, but if I use the method of substitution, that means if it's easier to find x first, I can use that and substitute into here to get the final answer. So if I look at this, I can make x the subject. If I divide both sides by tangent 60. So now I have x in terms of h. I can now substitute this into here. Okay, so if I substitute it into there, I get h over tangent 60 degrees plus 80 times tangent 45 degrees equals to h. Now we can try and solve for h. Okay, it looks like it's getting a bit complicated. So let me remove the bracket and I get h times h over tangent 60 degrees times tangent 45 degrees plus 80 times tangent 45 degrees is equal to h. Okay, and then I can try to make h the subject. So 80 tangent 45 degrees equals to, let me move this over to the other side, that would be h minus h tangent 45 degrees over tangent 60 degrees. And now I can factor out the h. That gives 1 minus this, tangent 45 over tangent 60. On the left is still 80 tangent 45 degrees. So finally I can divide both sides by that, okay, by this, and that leaves h on one side and 80 tangent 45 over 1 minus that. So now we can use our calculator to find this, and that would be the answer for the height. We'll stop here.